if you're thinking about like where would you, I don't know if this is like where would I need to stand to catch the object, or to where is it going to land in distance away, right? This is going to be, if this is like the house that you shoot it out from, or the building you shoot it from, right? Then it's going to land 265.68 feet away. Whoops, this is the building. It's going to land 265.68 feet away. So that's what that part C is asking. Okay. Okay, if we're going to look at part D there, so suppose we want the object to be 4 feet off the ground after traveling 240 feet. At what angle could we throw the object to make this happen? Okay, so this gives us a little bit different set of information. So we're changing that 30 degrees. The 30 degrees is not there, right, for ourselves. So if we think about this here, how would our equation change? Okay, right, if we go back to this equation, we're basically taking this out, right? So our x equation is 96 cosines of theta times t, and our y equation, right, is just going to be with that theta missing as well. So we have y equals, right, 10 minus 16t squared, right, plus 96 times the sine of theta degrees, or theta, times t. Okay, so those are our two equations we have for ourselves. So we want the object to be 4 feet off the ground after traveling 240 feet. So traveling 240, so that's a y value. So, oh sorry, that's an x value because it's traveling 240. So, right, I'll put it right in there. So I'll take the 240 equal to 96 cosine t. Okay, I'm going to figure out the time. So this is basically going to tell me, right, for myself, as I'm putting that in, sorry if I was off the bottom of the screen there. Right, this is going to tell me the time for any given angle. Right, for any given angle, this will tell me the time that it's going to be at 240 feet. Oh, that's great. I have that time. Okay. Now I can take that time and I can plug it in up here. 10 minus 16, right? Oh, let me try to reduce that first because that looks really big, and I bet both these can they can both be divided by 4. So, oh, they can both be divided by 4 again. So it's going to be 15 over 6. Oh, they can both be divided by 3. Yay. Okay. Wow. Not expecting that. Right. But 5 over 2. Right. So we're going to put in 5 over 2 cosine theta. That's better. At least it's easier to plug in. Right. Squared plus 96 sine theta times 5 over 2 cosine theta. Okay. So, oh, and this is going to be, and we want to know, suppose we want the object to be 4 feet off the ground, so let's find the angle that will make this true. And if you look at this, now we have an equation with one variable. We can do this, right? It doesn't look like it's going to be the most fun problem in the world, right, with all this algebra here. But let's see what we can do. Okay, so let's move this 10 over. Okay, and then we're going to have 96, right, times 5 sines of theta on the numerator, right, and then we have 2 cosines of theta in the denominator for myself, right. I'm just checking my work against my previous, right, to make sure I did everything right. Okay, I think I'm doing okay so far. .48 times 5, that's going to be, oh, we just did that before, that's 240. Okay, so I get to this, again, I'm just double checking here, folks, to see if I made any mistakes, right, for myself. Right. It looks like I'm doing okay so far. Yep, okay, so now I'm going to go to another piece of paper because that is getting super duper messy. Okay, so here we go. All right, let's try this one here. Okay, so I'm just going to copy that down. Okay, and now we're going to have a ton of fun in trying to solve this guy right here. Okay, yes, that was a little bit of sarcasm there for ourselves. All right, okay. And so as we look at this one here, right? What might I do for this one? Different options here, right? How about I change it to secant and tangent. I guess I could have multiplied everything by cosine there, right? Actually, let's try that. Let's try that instead, just so we don't have to have with sines and with the secants and cotangents. So let's try to scale this by cosine. Last year I did it by changing that way, and I'm going to go off the tracks here a little bit, see what we can do. Okay. For ourselves. Oh, we can see why that's not a great way to go for ourselves, because we have the sines and the cosines there. So yeah, bummer. I was going to try it. Hey, before I go any further, let me divide everything by -2 because I can, to make my numbers easier. So 3 cosine squareds equals 50 minus 120 sine theta cosine theta. Okay. All right. So, and just taking a look at that one, it looks like I'm going to have to move things around here. All right, I'm going to have to change the sines and cosines. So, it was nice. It was worth a try. So if I divide everything then by cosine squared, I'll get 3 equals 50 secant squareds minus 120. All right. So one of these cancels one of those, so I'm be left with a tangent of theta. And that's ideal because I can then go and I can then just replace this right here. Making sure I did everything right. That cancels that. Okay. Yeah. So by doing this, I'm dealing with secants and tangents. If I divided by sine squared, right, for myself, I would have been dealing with different trig functions. It's all just a personal preference here, but I'm going to go remembering that sine squared plus cosine squared of theta equals 1. Okay, so then the secant 1 is going to be tangent squared plus 1 equals secant squared theta. Okay, so how about I get rid of that secant squared theta? So I have 3 equals 50 okay. All right. So move things around. 50 tangent squareds of theta plus 50 minus 120 tangent thetas. Okay. So this is by far from pretty here, but it is what it is. So there's a chance that I've made a mistake here, right, in doing all this, but I think I'm pretty good here. Yep, I'm all good on my work there. Okay, so I'm in tangent land for this one. At this point, you're doing the quad formula for yourself. So now I'm gonna figure it out and do tangent of theta equaling negative b plus or minus the square root of b squared minus 4a c all over 2a all over 100. All right, figure out my angles. Okay. For myself, right? I get these angles, right? This will give me 2 angles for this. All right, let me pause this real quick and I'll get that so I don't waste your time with that. Okay, I just put it into my calculator here and I have tangent of theta equaling 1.9071 or 0.4929. Okay, I do my inverse trig and I get 26.237 degrees or 62.327 degrees. Okay, so we have 2 options there of which one we can use, and that's okay in this case, right? Totally valid. We could have 2 options there. Okay, so and follow-up questions I could ask. I could say, at what time will the ball reach this location with the angle? So if I have a part E here and it says when does it reach this location for each angle? Okay, so we had that. Then okay, all right, I would take I could take either equation. I'll take, I always like that easier one. All right, so we'll take that 240 equals 96, right, cosine of the angle that we have there, t, and you just plug that angle in there for yourself. You plug in the 26.237 in that angle, and then you just get, so it would be, the time would be 2.787 seconds for the smaller, and it would be about 5.383 seconds for the larger. Okay. Alright, so that's basically how you can do some of those problems. So look for my solutions, right, to be posted as well. I'm going to talk you through these. I think it's big ones, right? These usually take a couple days to do, even when I'm in class, so we'll do the best we can. Okay, thanks a lot, guys.